So this question asks you to find an equation of tangent plane to the surface. So first I'm going to find the partial of r respect to u and partial of r respect to v. So you have I plus 1/2 v uv to the negative 1/2. And then with respect to v would be j plus 1/2 uv to the negative 1/2. Alright, so at when r prime of 1, 1, you would plug 1 into this equation and 1 to this equation. So when u equal 1 and v equal 1 and u equal 1, v equal 1 for both partial derivatives, because they give you at the specific point of 1, 1, 1. Alright, so if partial of r respect to u at 1, 1, you'll get 1 of I plus 1/2 of k. Then partial of r respect to v, 1 on 1, you get 1 of j plus 1/2 k. Now you have two vectors. You can find the cross product of the two to find the tangent plane, or the vectors, or the orthogonal vector. Okay, so I'm gonna rewrite these two vectors into bracket notation, so I can go ahead and do the cross product. So you get 1, 0, 1/2, 0, 1, 1/2. Now find a cross product of the partial of r respect to u at 1, 1 cross partial of r respect to v at 1, 1. So you just find a cross product, you get 0 minus 1/2 negative 1/2 minus 0 and 1 minus 0. So your cross product is negative 1/2, negative 1/2, and 1. Alright, now you can just go ahead and use the orthogonal vector to find the tangent plane. So you will have negative 1/2 x minus x naught minus 1/2 y minus y naught and plus 1 of z minus z naught equals 0. And these x naught, y naught, and z naughts are 1, 1, and 1. The point they gave us in the beginning. So now you have negative 1/2 x minus 1 minus 1/2 y minus 1 plus z minus 1. This is your correct answer. But you can also go ahead and simplify this further. If you simplify this, you'll get x plus y minus 2z equals 0.